So I'm going to tell you the story of a place called Matterville. All right, so this is a place called Matterville. There's probably an adjacent community on either side, but right now we're talking about a place called Matterville. And in the middle of Matterville is this cool place called the Nucleus Arcade. Harmony, would you mind shutting the door, please? Two different types of individuals live in the Nucleus Arcade, and without sounding mean, I'm just going to say that they're somewhat husky. They're big bones. And the first one that I'm going to talk about is a lovely lady called Positive Patty Proton. Positive Patty Proton has eyes that sparkle and a very sunny, smiley disposition. As I said, she's husky. And I'm not really drawing clothes on Positive Patty Proton because it's not that she's naked, it's just that I'm not very good at drawing clothes. So if you want to add clothing to your own diagram, but just for the record, this is not a nude arcade. This is just a teacher not being able to draw clothes very well. Maybe I'll just put a little dress on her. Something that violates the dress code. That looks more like an apron, but oh goodness, I have a feeling things would be kind of sticking out there. Cover some of that stuff up. All right. Patty has such a positive personality, and she can take any situation and look at it in a positive way. For example, the other day, her grandma called her and says, "Patty, I have some tragic news. Your favorite dog was hit by a car today, died on impact." And Patty says, "Well, it just must be that his time had come. At least he didn't suffer much. He was up there in age anyway, right? Taking a positive spin on things." So she can take the worst of news and turn it into something positive. Notice her eyes that sparkle, indicating her positive personality. Also in the Nucleus Arcade is another hefty lady, and her name is Nerdy Nelda Neutron. Nelda has a personality that is very almost non-existent. She doesn't get excited about much. She doesn't get happy. She doesn't get sad. She just kind of remains with vacant eyes, no expression, zero expression. Notice the zeros. And a straight face, like this. This is not easy. You should try it. So, I was smiling?
A little bit.
I'm telling you, it's not easy. It's not easy being a Nelda. So, Nelda's sitting in the Nucleus Arcade just hanging out. She can't go anywhere else. This is just where they are, right? And Ed McMahon comes to the door, and Ed says, "Nelda, you have won $1 million. It's a sweepstakes." And her response is this. Right? She doesn't get happy. She doesn't get sad. Grandma calls her to tell her dog died. Nothing. You can't tell what's going on in there because there's nothing going on. It's not that I don't want to say that she's slow. or anything like that. I'm just saying she's expressionless. Not like Patty. She's happy all the time. Okay. So outside the Nucleus Arcade are some roadways. They're called electron roadways. I'm going to draw 3 for now. There are more. On the electron roadways exists a character named Enraged Elliott Electron. And he rides on these roadways on his chrome-plated Harley-Davidson so fast that you can't tell where he is at any given time. He's just really fast. So I will do my best at attempting to draw a Harley-Davidson. I haven't seen one lately. It's going to be the kind that has one of those really low seats. So there's a seat. Maybe a gas tank here with some flames. Maybe coming from the gas tank are some big chopper handlebars.
That looks like a bug.
Yeah, it does look like a bug.
You need, oh, there we go. Wheels. Soon.
You guys.
So one wheel.
No, I'm still working on it. I sense a little criticism here. This is a tough crowd. I'm trying. All right. So I think that somewhere under the gas tank there are some other things. I know there's a spot to put feet. There's a pipe. And some other things.
Oh. There's the second wheel.
There's the second wheel.
That's no fenders.
Here's Elliot.
He's nice.
You can tell that there's just not much to him, right? He's got to sit a little bit lower and bring his arms up on his chopper and his legs down. His head is right there.
Wow.
But what can you say about Elliot compared to the ladies in the Nucleus Arcade? He's almost non-existent comparatively. But I'm going to draw a big head just for giggles. Here's a caricature of Elliot. Isn't that a caricature where they make the head a little bit bigger and the body small? All right, here's Elliot's caricature. He has squinty eyes because he's mad. I don't know how he drives like that with his eyes closed, but he is angry much of the time because they won't let him in the Nucleus Arcade. Enraged Elliott Electron. Very negative. He's a dark cloud in the room. Negative Nancy. All right. Now, Elliot can exist on these roadways, and that's the only place he can exist. And he could be on any of the roadways, but he can't go through the ditches to go from one road to the other. And there are no roads connecting these roadways. So how is Elliot going to manage? What? He's going to jump. He's going to have sweet jumps. Have you ever seen Napoleon Dynamite?
Yes.
Napoleon Dynamite has sweet jumps. So does Enraged Elliott Electron. There's one. Sweet jump. He can jump from here to here. He can jump from any of these places. But he's always on these roads. And he can jump from one road to the other. So, this road right here is probably the smallest. It's closest to the Nucleus Arcade. There's only enough room for a certain number of Elliott Electron brothers. So if there were some more Elliott brothers in here, does anyone know how many Elliots could ride their motorcycles on that first road? Twilight? 2. All right, you're right. I'm just going to write it 2. 2 Enraged Electron Elliots. What about on the next road, a little bit further out from the nucleus? Haley? 8. 8 is right. There is enough room for 8 electrons, electron brothers to ride on their motorcycles. All right, what about the third? Ellie? You say 8 because that's what you've been taught. But we've been telling you a little fib. It's actually 18. So you remember 288? Weird. There's no doubt about it. Things get weird. But I will tell you that 8 is significant, and that's why we've taught it 288. Because number one, all of the elements that you've learned about so far have never really had any more than 8 electrons in that third energy level. But there's something called an octet rule. Octet refers to the number 8. And we have discovered that if the outermost electron shell has 8 electrons in it, the element is stable. So if it's got 8, it's great. Okay, so there is something significant. It wasn't all in jest that anyone lied to you on purpose. Maybe the other teachers that have had this don't know that it can hold 18, but this third can hold 18. The fourth can hold up to 32. But if it has 8, it is great. It's considered stable. All right, so what if Elliot leaves and takes his negativeness with him? How does the overall morale of Matterville change? It becomes more positive. So Elliot leaves, he's not around anymore. Got positive Patty in the nucleus. Nelda, she's not contributing to the morale at all, but it becomes more positive. What if some electrons come in from some neighboring cities and start buzzing around these roads with Elliot electrons? Say there's 2 Elliot electrons. The overall morale would be negative. So if you have more electron Elliots than you have positive Patty protons, you have a negative Matterville. What about right now where I have 1 of each? It's neutral. The overall morale of Matterville is neutral. So, positive Patty proton, nerdy Nelda in the nucleus arcade. What happens if I add more Neldas? How does the overall morale change? It doesn't. Adding more Neldas doesn't really affect anything having to do with the morale or the overall charge. It can cause some instability in the nucleus. In fact, elements that have a high number of nerdy Nelda neutrons compared to protons are, they will actually radioactively decay because the nucleus is unstable, so nuclear reactions will occur. So when the atom is neutral, we have as many positive Patties as we have enraged Elliot electrons, and the overall morale is neutral. So look at your drawing of the atom, and if you need to make changes, please make changes. Draw an atom and label its parts on the whiteboard. I have a handout for you. It's a resource.
I'm sure we're supposed to be released with volleyball. Like,
I don't think that I can let you leave unless there's an awful.
here you go, Lucas. You're welcome.
I don't think I do.
All of it?
Checking it out. Just like that was late. She didn't check.
Teacher, please excuse this interruption. At this time, our girls volleyball team is ready.
Good luck. Are you the only one?
I think so.
Yeah. Have fun. That last game was really awesome and exciting. Okay, I've given you a resource here. And there's a lot of information. You'll see that it has kind of a general structure of an atom. There's two different elements represented here, neon and sodium. You'll see here that it says in the first electron shell, you can have 2 electrons, in the second 8, and the third up to 18. What we're going to do right now is we're going to just summarize this chart in our notes. So let's write, create a chart. We'll call it the particle symbol, mass, charge, and we have the proton, the neutron, and the electron. The symbol that we use for a proton is a lowercase p with a little plus sign written as a subscript, superscript. The symbol we use for a neutron is an N with a 0. One place that people made mistakes as I was looking at the atoms is they were putting plus signs and negative signs in the nucleus. We have no negativity in the nucleus arcade. It's always a fun place to be. I mean, Nelda might not be having fun, but she's not hating it either, right? The nucleus is always positive. Negative, out here with Elliot. The symbol for the electron is a small letter E with a negative sign. With Patty and Nelda being husky, we say that they have about equal masses. Nelda's just a little tiny bit more massive than Patty, but they're about the same. We say that they have a mass of 1. Elliot electron is so small that his mass is negligible, and we say that he has a mass of 0. The value of the charge on a proton is +1. A neutron is 0. And an electron is -1. You know, I have 2 class periods off during the day. And I'm sitting here thinking, oh my God, I'm so tired. And then I have to think about all of you who have 8 hours each day and you just go, go, go. And no study halls. So I need to quit complaining. Because you have a lot worse than I do. But I feel kind of tired at this time of day. So the next thing that I want to teach you is just some definitions. Technically, this should all be review if you're not feeling like that, maybe you're just kind of far away from it, I'm hoping that my story will help you imagine the structure of the atom. What do you think?
Yeah.
I hope so. Some of the drawings throughout the day have been like, I've seen this. I've seen this. I've seen this. Which, I guess other than
That's
that,
kind of how they talk.
yeah, because you've used tick marks as electrons, I think, in the past, but the nucleus won't be negative. But the drawings that you have right now are a lot better. Uh-oh, I didn't mean to do that. Imagine that it's still there. Okay. The next thing that I want to talk to you about are some symbols that you see on the periodic table and what they mean. Again, I hope it's review. But I'm going to take the aluminum and I'm going to just kind of blow it up into a big block. So I'm looking at the aluminum block up there. I see a 13. I see the symbol Al. Underneath it, it says aluminum. And underneath that, I see a 26.98. Okay. Does anyone know what this lower number, this whole number represents? Teresa? It can represent where it is on the periodic table. But there's something special about this number. Haley? Okay. So it is accurate. It is the number of protons. If it's a neutral atom, the number of electrons. But sometimes electrons can be different if you get a charged particle. What is the name of this number? Yep, that's the atomic number. So the atomic number is the small whole number on the periodic table. Cord is attacking me. And it indicates the number of protons in an atom. And if the atom is neutral, it indicates the number of electrons. I'm sorry, that's getting kind of sloppy back there. Okay. The next thing I want to do is I want to look at this number. But let's say that Madrigal here is aluminum. We have 13 positive Patty protons. How many neutrons? How many nerdy Neldas? It could be. It could be 16. It could be 12. Even though there are 13 positive Patty protons, because there are 13, it makes this aluminum, but this can vary. So there are, in a sample of aluminum, so this, let's say I have all these aluminum atoms. They all have 13 protons, but let's say most of them have 14 electrons, but some have 13, some have 12, some have 16, some have 17. So some of the aluminum atoms are heavier than others because there's more nerdy Neldas. So this number right here is the atomic mass. It's an average mass of all of the different types of that element. So atomic mass, which is this, and I apologize if that really screwed up your notes at all. I don't know if you can just send an arrow from wherever you wrote that to that. The atomic mass is the average mass of all types of each element. And those are called isotopes, which we will talk more in detail about later. The other number that we're going to talk about is the mass number. Yep. Huh? You got it? Okay. The mass number is the sum of the number of protons plus the number of neutrons. In the past, you've been told to take that atomic mass and just round it to the nearest whole number. Yes? And I'm guessing that's why somebody said there would be 14 neutrons, because you've, by practice, taken this 26.98 and rounded it to 27. The 27 is probably the most common type of aluminum. So let's say that in Meadorville we do have 14. So in this case, the mass number would be 27. We're just adding up Patty's and Nelda's. So the mass number, the number of protons, plus the number of neutrons. Now I'm going to show you how to make a complete chemical symbol. The complete symbol will have the element symbol. Right here, it's going to have the mass number. Right here, it's going to have the atomic number. In this case, 13 and 27. This is the complete symbol. For this particular type of aluminum, we're talking about an aluminum with 14 neutrons, 13 protons, and 13 electrons if it's neutral. Oh. I want to remind you that we're having a quiz on Friday. On the quiz, we'll have lab identification, lab equipment identification. We'll need to know how the uses of lab equipment, lab safety, and the stuff that we learned today and Thursday. Pass it that way, please. I'm giving you guys something right now that's, you probably get mad at me.
Oh no.
And we're going to work it on in class, but my rule is that you cannot do it at home. Some of you are going to be tempted and you're not going to be able to control yourself. But we're not going to do this at home. This is called, yeah, the notes. Review of atomic structure.
I just put notes.
I think that's what I called it in the lesson. Okay. This is going to seem like tedious, busy work, and I have to tell you, my philosophy does not believe in busy work that has no meaning. So I will not ask you to do something that I don't think has value. The repetitive nature of this is going to provide the foundation or build upon a foundation that already exists that will help you succeed over the next 2 weeks. And this is going to be for the first 18 elements. And what you see there is you see in the upper right-hand corner, if you look at the oxygen as an example, you see a complete symbol with the mass number and the atomic number, the name of the element, what's in the nucleus, and also the electrons being distributed as dots. And it says in the atomic structure diagram, we're including the number of protons and neutrons in the nucleus, also the number of electrons distributed in shells using a 288 format. 288, I didn't want to put 2818 because that would be confusing because you're never going to get more than 8 at this one. Okay, so there is something significant about 8. So that's the pattern that you're going to see. So I've done oxygen for you. This is going to be hydrogen, helium, and then 3, 4, 5, 6, 7, 8. Oxygen's going to go right here. 9, 10, 11, 12, 13, 14, 15, 16, 17. I think I would like to do element number 15 as an example right now. So that one would go here. 11, 12, 13, 14, 15. What element is 15? Phosphorus. Phosphorus. So I'm going to write phosphorus here. You can use this as a guide for how big you need to make things, and I might encourage you to use a pencil if you've got one. The next thing is the complete chemical symbol. Phosphorus, the atomic number is 15. The mass, the atomic mass is 30.97. So the most common type of phosphorus probably has a mass number of 31. So we'll take that and we'll round it to the nearest whole number. All right. First, we got to start. Next thing, draw what's in the nucleus. In the nucleus, we have protons and neutrons. How many protons in this case? 15. If my mass number is 31 and all of my mass is in this nucleus arcade with our hefty gals, how many nerdy Neldas do we have? 16. Because our mass number is 31. The next thing we have to do is add electrons. How many electrons can fit in the first shell? 2. We're going to add them as dots, and we'll do top, bottom. I would like you to distribute the electrons the same way every time, so we're all doing it exactly the same. All right, I can't put any more on this electron energy level, so I'm going to add the next one. And even though I'm going to completely fill it, I'm going to add the electrons in a certain way, and that's top, bottom, left, right. So 1, 2, 3, 4, 5, 6, 7, back up to the top, 8, bottom, 9, left, 10, right. All right, I have a total of 10 electrons. I still need to put 5 more on there because we're talking about neutral atoms. So 11, 12, 13, 14, back up to the top for 15. There is a reason I'm having you put electrons on like that. 2 reasons. One is so that all of our drawings look the same. And the other is something that's still to come.